All right, for today, what we're going to talk about is the continuity and end behavior of a function. So, a couple of things you need to know about is when you talk about continuous, what makes a function continuous? Well, a function is continuous. Continuous is if there is no breaks or jumps or holes. So ideally, one would argue that if you could take your pen, or if you literally cannot take your, like, you can draw the function and your pencil or your pen or your finger doesn't come off the paper. So what's discontinuous? Is discontinuous is having holes, jumps, or breaks. So best way to look at that is to look at this, the first one, this guy right here. This is what you would consider infinite discontinuity. All right, and I guess you could say this is infinite discontinuity. Why is it infinite? Because of right here. See, what happens is you can see this little line right here. Boom, 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 boom. That guy right there, that's an asymptote. So it is a there's a you'd see it graphically. It jumps. It goes. This is a hyperbola. So from here it goes and it jumps over to this other side. So that's a jump, but really you have an asymptote. So as I go from as I come from the left, I'm approaching a vertical asymptote, and then as I come from the as I come from the right, I go this way. As I come from the left, I go this way. That's an infinite discontinuity. So when the function increases or decreases infinitely as I approach from the left or the right. So if you see, if I'm coming in from the left right here, I'm going up to positive infinity. As I approach, looks like negative 3. When I come from the right, I'm approaching negative infinity. So that's an example of infinite discontinuity. What does a jump look like? Well, here's one, and the problem with this guy is you can't really see it, but this is supposed to be an open circle there and a solid circle right there. So this is a literal a jump. All right. At this point, looks like it jumps from 0 and it comes up here. So it's open and closed. See how it jumps? That's considered a jump. This is what a jump looks like. And you see this in what's called a piecewise function. That's what that is, right? And then this last one, you can't see it, but right here, that's a hole. Okay. So, like, the function wise, this guy is something like a f of x equals like 1 over x. That's a hyperbola. This guy can be like a piecewise function. So it'd be like negative 2x from like negative 1 to 2. And then this is equals to 3 from like 2 to infinity or something. This one is what's called a removable discontinuity at this spot right here, because this is x. This is actually, if I graph this, this is the function x minus 1 over x minus 2 times like x minus 2. Those go away, so it looks like a line. So that's a removable discontinuity. So you need to be mindful of what you have there. All right. Another thing when you talk about graphs is you're talking about end behavior. Now, back in algebra 2 or advanced algebra 2, you talked about down down end behavior, up end behavior, down up end behavior, etc., etc. But basically, what do we talk about is what end behavior is. It is what happens when you go way to the left or way to the right. So for like this is a polynomial. So how do I write this? I say as x approaches infinity. What does that mean? That means as x gets ginormously big going to the right, what do you see this going? This actually is heading towards infinity. So the function is heading towards negative infinity. It's getting super duper small. What about when x approaches negative infinity? So what does that mean? That means when x gets super duper small. So if I zoom this out, this goes forever, then this guy, this particular function, the function itself is going to be approaching positive infinity. And it just depends on what you're looking at. Um, so you can approach on your end behavior, you can approach positive or negative infinity, but sometimes it approaches a particular value. Let's look at this guy right here. If we look at it as x approaches negative infinity, that means x gets super duper small. So as x gets super duper duper small, going this way to the left, the function actually is approaching 0. But what about when I get really, really big? As x approaches something ginormous like positive infinity, what happens? As I get x bigger and bigger, oh, look at that. It's also approaching 0. So that happens. And that's what it means to be approaching certain values. So there's not a whole lot more to explain. I guess you can practice this a little bit if you wanted to, and that's fine. And I look forward to seeing you in class, and may the force be with you.